Awesome. Okay. Yeah. So welcome, one and all. This is the first AIE working group meeting for KubeVirt. Over 2 seconds. Oh, okay. Just Andrew's just talking to me about the meeting setup. Sorry about the initial teething problems. We've had to obviously create this ad hoc meeting after the original meeting was scheduled in the middle of KubeCon, so no one could attend. So apologies about that. Thank you all for attending today. If I could just ask everyone to add their names to the attendees list in today's agenda, I will copy the link into chat again, just in case anyone's missed it. And yeah, the agenda for today, I just want to give a brief kind of introduction to the working group, the very basic charter that we have at the moment, the kind of background to this working group and the CentOS SIG. I would then like us to briefly talk about the current KubeVirt AIE project that we have underway, and kind of describe what we're trying to do with that project. And then hopefully conversations will kind of naturally flow into what we could potentially can do during the current 1.9 development window for KubeVirt, in terms of upstreaming that work and incorporating work from other folks and from other vendors and other contributors upstream. So to begin with, again, welcome everyone. My name is Lee Yarwood. I'm a software engineer at Red Hat. I'm one of the chairs of this group. Ale, do you want to introduce yourself as the co-chair as well?
Yes, sure. Hi, everyone. My name is Alay. I'm engineer on the NVIDIA side, working on KubeVirt and DRA and other things in Kubernetes community.
Thank you. And yeah, the charter at the moment for this working group is very brief by design. We will be looking to expand it as things kind of progress with the working group. For now, it is just to track and extend KubeVirt in line with the CentOS Stream AIE SIG. The AIE SIG itself, so AIE itself stands for Accelerated Infrastructure Enablement. It's all very generic, but it is a CentOS SIG, so a true CentOS SIG, aimed at delivering. Yeah, I'm not going to read the blurb here because it's all very fluffy, but just accelerated hardware enablement essentially through CentOS Stream, through a specific SIG. It's beginning focus. The initial focus is going to be on the video hardware, so that's the current focus, and that's how the actual charter for that SIG is kind of skewed at the moment. And yeah, the working group within KubeVirt is just focused on tracking their work and extending KubeVirt when and where possible, essentially to consume that work. Yeah. Any comments, questions, or thoughts on the charter as is at the moment? Like I said, it's very generic, but yeah. Any thoughts at the moment on that initial part?
Is this meant to be like a working group in the sense that in the Kubernetes definition and like we work towards a goal and then the working group ends after that goal is achieved? Is that how this is intended?
Yeah, most likely. So the SIG, the CentOS Stream SIG upstream, is initially focusing just on this NVIDIA hardware. That there are likely to be other such endeavors in the future. This working group at the moment isn't kind of, how can I put this, namespaced or like locked in on just this NVIDIA support at the moment. We could change the charter and the name of the group so that it is specific just to this kind of round of enablement, and potentially have a fresh working group for the next kind of iterations or for different partners or different hardware enablement in the future. But yeah, it's a bit open ended at the moment because we weren't sure. Like I don't think anyone's really sure on the kind of direction this is all going to take and how long it's actually going to take to achieve. this time around. But yeah, going forwards, we could easily kind of rename and rework the kind of charter of the working group to be a bit shorter term and everything in align with a particular kind of hardware set coming online and all that stuff.
So then maybe the next question is like, or maybe we're going to get to this in the next section. It's like how we view KubeVirt AIE is like, is it meant to be a project that is, so you talked about accelerating the development path and then in the charter. And it's the idea like we take KubeVirt AIE and it eventually merges into tree and then the project goes away. Like is that and then we continue on with kind of like a sprint group, like we're working toward a goal and then we eventually get it into a release. And then we don't maintain that project over the long term.
No, I think, I mean, in my head, this is pretty much some kind of a snapshot of what we have right now. We are working towards, enabling certain functionalities that are outside of KubeVirt scope because KubeVirt doesn't support XYZ, and things that we need to use right now. They are not in stable kernel. They are not in stable library. They are not in stable QEMU. So we need to branch out, do the work, and then see how to bring it in back into KubeVirt. And these kind of iterations could be with the NVIDIA hardware, it could be with the whatever other partner. There's some other things that are going on with other partners. But I mean, the idea is that we will take something, work on it outside of, basically do whatever is necessary to support that particular platform, and then try to bring it in back to KubeVirt and go on and continue to other tasks.
Yeah,
So
I think my
ahead.
mental model of this working group was that because there are things that cannot be put in core KubeVirt, we need a separate uh, set of infrastructure to expedite that and give it to users. But in parallel, like when we do this expedition, we need to keep thinking about how we can merge this back into core KubeVirt, and given enough time, let's say 3 releases, just throwing out random number of releases, but given enough time, this work group will contribute everything that was developed back into KubeVirt, or at least have a path to that. That was my mental model. Someone can correct me if this is inaccurate.
I wanted to understand the intended role of the KubeVirt AIE. Is it a staging branch or integration fork or a long-lived downstream fork?
It's really a long-lived. I wouldn't call it downstream. I'd call it midstream fork. So yeah, as others have said, a lot of the work that's happening there at the moment was specifically working against the 1.8 release branch. And we have our own version of that branch that we're syncing. But because the various kind of lower level components, so libvirt, QEMU, kernel, that we're getting from the CentOS Stream SIG, because those changes aren't upstreamed and available in vanilla CentOS Stream 9. We needed a place where we could also kind of iterate and work on potential KubeVirt changes to actually support this hardware in a reasonable time frame. So that's why the project is there and the branch is there for now. And as others have said, the medium term goal is then to upstream this in a reasonable way, in a collaborative way, back into KubeVirt main, once we've figured out a way of enabling stuff as quickly as possible in the KubeVirt AIE brand project.
What I would add is that we don't want to do anything behind closed doors. We want to show the progress, and we want to see get reviews and try to collaborate on things that we are currently doing in order to enable certain platforms. And again, we don't want to do it behind closed doors. This is still KubeVirt, so we want to show what's going on, collaborate, and then bring it back into the main branch.
Yeah, it makes sense, Vladik. It's the point I'm just emphasizing is what we're not doing here is we're not creating some sort of fork that's going to stand next to KubeVirt and we use it as sort of a way to accelerate certain features over the long term. We're not doing that. We're not, because that's going to divide the community. I think it's just going to cause problems for us, right? So yeah. I just wanted to clarify that the effort is we're trying to, like I said, we don't want certain accelerators and the work to enable this to be behind closed doors. So we're going to open source this, and then eventually this will make it all its way all the way back into the KubeVirt repo.
Absolutely, and one of the things that we want to keep here is that we need to develop something not hacky that actually eventually will find its way back to KubeVirt. So I think that's one of the main reasons to open this up for reviews and collaboration.
Great, thanks.
I have another question. So, is upstream convergence a real project goal of this AIE or only aspiration?
I think it's a real project goal. It's a real goal of the working group to not only just do the initial enablement, but also to collaborate and work through the enhancement process and come up with a non-hacky solution, as Vladik said, that we can then land in main and can be, the longer term kind of version of the feature or the enablement within KubeVirt itself.
Yeah, I would even word it more strongly. I think it's a requirement that I think to measure success for AIE is means that we find a good solution for enabling these accelerators inside of KubeVirt. And that's and so the AIE is we're incubating, we're trying to meet the timelines, and we're doing it in the open. And so the requirement is that eventually all of that makes it back as a full solution to KubeVirt.
Yeah, that's definitely fair. Yeah.
Yeah, I think I would like to summarize the goal here in two pillars. The first pillar is to explore and do the work that is necessary to meet the given timelines in this fork. And then the second pillar is take this fork, put all of the exploration that is done here and put it back in KubeVirt main. And in order to, as Ryan said, for success, we need both the pillars to progress given enough time.
Yeah, definitely. Sorry, my kids have just got back from school. Vladik, do you just want to? Is there anything extra that you want to cover regarding, how we've approached it, the initial implementation within the KubeVirt AIE group project, and the webhook and the device plugin and stuff? Do you want to talk to that?
Yeah. So sure. There were a few challenges when we started with this effort, and one of them was to consolidate everything in a component that is unprivileged. The goal here was to kind of base the work on the Virt launcher. So Virt launcher will be able to discover everything it needs to configure the different parts of the hardware. And the idea was that we will just bring all the different components like libvirt, libvirt, kernel, and whatever changes needed in QEMU under one hood, and then kind of improve the Virt launcher for the Virt launcher code itself, so it will become aware of all of these new configurations and how to configure them. And it's great that it was done in parallel to some work that was going on in KubeVirt already, that was configuring the PCI topology based on NUMA nodes, so turning it into NUMA aware. And then with all of these changes, we try to start VMs, and there were a few challenges that we come across. For example, with how memory is being accounted with the new IMMUFD. And so for this effort, we had to create a separate device plugin that opens the IMMUFD device, changes the mode for accounting memory, and then streaming a file descriptor back into KubeVirt. And then there we had to work with libvirt to allow them to kind of accept the file descriptor and then stream it back to QEMU. There were a few other challenges with this hardware that we had to overcome, like for example, a memory leak that we discovered in libvirt. So basically, there were multiple changes that we had to do, but the good part is that we were able to not to spread this code across like multiple components. We were able to reuse the NVIDIA device plugin device plugin, and add additional device plugin, and then rest of the things were consolidated in Virt Launcher, like I said. The only thing is that we needed to do is to switch the Virt Launcher image that is dedicated for this work, rather than using the regular Virt Launcher. So what we have all in all is basically a platform that is based on KubeVirt 1.8. There's a webhook that identifies these specific workloads that need a new Virt Launcher image and changes it. And then there's a new generic device plugin that streams a file descriptor of a pre-opened IMMUFD device. And then, of course, changes in the Virt Launcher itself.
Thank you, Vladek. So there are a couple of questions below. Vladek, in terms of 1.8, what we have working thus far is Grace Hopper and Grace Blackwell pass through, right? And just singular GPU pass through at the moment.
Yes. So, well, actually, we were testing now with 2 GPUs and multiple VMs on the same node, but that's still ongoing. But yes, I mean, in general, we would like to create a new web or base it on an existing web, and list all the changes that we need to do for the Virt Launcher. The IMMUFD device plugin is already you moved it, Lee, to the KubeVirt org, so it's a public project already. And then the part that is less known is how we identify the workloads that really need this specific functionality. But yeah, that's something for debate, I guess. Or maybe nothing is needed, really.
Right, sorry. And yeah, the additional questions then about what the plan is for 1.9 and what the timeline is for convergence upstream with KubeVirt. Like, yeah, we'd like to converge in 1.9. We'd like to push this back up in 1.9. The next step of that is what Vladik said about taking the existing VEPs and aligning them or adjusting them to what we've experienced, and this not the use case that we specifically have, but the more generic use case of launcher being unprivileged and needing the changes that we've had to kind of work through. So yeah, that's the plan for 1.9. There's an additional question here about independent releases from KubeVirt AIE. There's no plan to have any such releases. We are providing builds of the Virt launcher image, but there's no formal releases from 1.8 AIE.
I've got a process question. Are all of these all the features that we know about, are they all in VEPs right now? And is that how is that how we're tracking what goes into AIE that'll eventually make its way back to KubeVirt? Would we use VEPs to track that?
Yes, yeah, of course. So we have the Web 115 that is talking about PCI, NUMA-aware PCI topology. That one is alpha in 1.8. We built on top of that in this working group. So basically, there are extensions there that are needed, but we already have a web, and this one should go to beta. And then for the inference of SMMU and all kind of other things that are needed to configure the Virt launcher to run on ARM and on this specific hardware, that we need a web for. For this one, we need a web. I think there's a generic one that is kind of open right now, but there are no specifics in there. So I think we need to add the substance in there. And then the device plugin. So the introduction of the device plugin. So I think that could be also handled inside one web. So yes, to your question, yeah, definitely all of it will have to go to web.
Sorry, Brian, just to butt in. Were you asking if we had VEPs for the work that we were doing in the KubeVirt AIE project initially, or was it Vladik's point about what comes next and getting this back into KubeVirt main?
I would say I'm asking about the features we're aware about that we're tracking that we'd like to get in KubeVirt. Maybe there's some of them are there right now. And then there's some features that we want to accelerate by getting into AIE. So I was asking like the ones we want to accelerate that we're eventually going to bring back to KubeVirt. Like I'm assuming those are in VEPs or we'll use VEPs and that's how we'll track them.
Yeah, going forward, we're going to use the VEPs that Vlad was talking about to kind of track them back into main. Initially, for this effort, we haven't been using VEPs to kind of capture the initial kind of changes in design that we've gone with this initial iteration of KubeVirt AIE. We could potentially in the future, but yeah, the VEPs that we have are specifically targeted at KubeVirt main, and are like the follow-up kind of upstreaming work, if you will. Enablement.
Hey, sorry, I had a suggestion around this. Lee, it would be great to have a document that can describe all of the things that were needed for this fork, and then link back to the VEPs that has more long-term feature integration or feature development in KubeVirt. I can work with you on that document, but I think that will help answer Ryan, and more general community questions around how this work is evolving, and we can, keep updating it as new things are discovered.
Yeah, definitely. Yeah, that having a tracking document like that would be good. Yeah. Apologies for not having something written down ahead of time, but yeah, we can go through the open enhancements and kind of link them back to the work that we've done. It's even going to cover things like the CentOS Stream 10 enablement stuff that we have lined up for 1.9 now as well. Like that's part of it as well. But yeah, we can definitely work on that in the coming weeks.
Yeah. So for Fan's point, I think first of all, I invite you to review the code that went into the project. Specifically, I think PR number 10. So from this list, basically most of these things that have been covered in Web 10. I'm not sure what libvirt are you guys using, but yeah, we had to do a lot of changes in libvirt as well. There were some memory leaks and all kind of other things, but EGM was out of scope for this work, and yeah. Our main push here is that Virt Launcher has to be unprivileged and rootless. So all of this work that we've been doing is to enable this use case. They just have to be kind of naturally.
Yeah. So yeah, so in our downstream work, the libvirt, we use we use the NVIDIA patches, the QEMU and the libvirt from the NVIDIA open source, the GitHub repo. So we built the RPMs internally. So yeah, we did the I think we did the similar thing to modify the Bazel build scripts, RPM scripts to wire these RPMs for the KubeVirt. Yeah, so I think we did a similar thing.
Yeah, I don't know. It's always better to work upstream. So that's why I think CentOS created this open source repository for libvirt and QEMU and the kernel. But the things that you mentioned here, for example, PCI hole configuration, that is already, I mean, we configure this as part of inference and configure this as part of the Virt launcher, not inside libvirt. So I basically invite you to review and maybe contribute to what we already have. I mean, that's the point. That's the point of the working group. So we'll be able to put these things in and then bring it back into KubeVirt.
Yeah. So yeah, yeah, I will have a look at. That's very interesting. Yeah, so I think for the RPMs, I'm not sure if you have heard of the Red Hat for NV, the project that collaborate between Red Hat and NVIDIA. Um, so they're going to release the RPMs as well. I noticed that you are using some RPMs in the Koji Harp stream CentOS, right?
Yeah,
Uh,
this is the upstream of that effort. So this is the same code as the downstream rail for MV effort.
yeah, that's good. Yeah, that's the same thing we are going to move to from our internal development to RPMs. Um, so I would like to know how would you test the RPMs, or and do you have the pipeline to test the RPMs, and uh, how would you um, build and pick the latest changes of the NVIDIA patches?
So we are not directly responsible for those RPMs. So there's separate teams at Red Hat that work on the upstream kind of CentOS SIG side of this, both across Virt and kernel. So they're ultimately responsible for providing those, and they are the ones kind of upstreaming the original NVIDIA patches and putting them into this SIG, and then formally placing them upstream into the original projects as well. In terms of how we're picking them up, there's a simple script within the KubeVirt AIE branch that we have at the moment. I think it's sync NV RPMs or something that's pulling them directly from Koji. There are composes available as well that are kind of mini repos. They've only become available recently, so we haven't switched over to using them yet. But you can potentially pull RPMs directly from a miniature repo as well for this effort. And in terms of testing for the project at the moment, we've only got very simplistic lanes set up at the moment on ARM for linting and unit testing and some basic functional testing as well. We don't actually have any direct GPU pass-through testing or anything in CI because we're lacking in hardware. So if you know anyone with a few spare Grace systems, there may be a few people on the call. Yeah, we gratefully receive anything that we can get upstream for that as well. But yeah, that's what we have at the moment.
Haley, correct me if I'm wrong, but we need someone to actually take what is there in the fork and try it out on the hardware, right?
Yeah, so downstream we do have access to a limited number of systems, so we have been doing actual real world testing with this as well. Sorry, I didn't mean to imply we hadn't actually tested it. We have been testing this against real hardware as well. But just in terms of upstream, we don't have any upstream CI kind of covering Grace in any sense at the moment.
Yeah. So I think there are a lot of gaps between the upstream KubeVirt and the AIE, including the CI pipelines to testing the Grace specific features, right?
Yeah, I mean, the idea is that we'll build it upstream, get into some sort of image that can be testable on an existing 1.8 deployment, sort of, and then those who have hardware can just test it, just run VMs with it. But yeah, I mean, we don't have an upstream CI, unfortunately.
Yeah, Fan, I think yeah, like the fun exciting. I think like since well, it's probably at least I don't know, but like the upstream hardware and how we can procure that, and that'll definitely be a discussion we'll have to think about. But there's also I mean, Fan, like in the meantime, I would take AIE and try and run the pipeline on the systems that you have access to now, and we can build the CI at least internally for a while. We can communicate back some of the feedback on the pipeline. I think um, that would at least answer some of your questions as to like the existing CI that runs there, and then I think longer term we'd have to figure out like how we can procure hardware for upstream. This will at least give us like that accelerated path for the near term for your testing plan.
Yeah. It would be great to have at least sort of the limited internal CI. We have some hardware, so we can. Yeah, so it would be better. It would be great to have at least some CI to test the features and PRs.
Yeah, let's do that. Let's take that in internally and let's work on that just while we can get it off the ground and accelerate. And then I think then the longer term we're gonna have to figure out how, the upstream CI question.
Go ahead.
Yeah, sorry. Yeah, so I think, yeah, I will to look at the PR10. So, my question was, we have achieved a bunch of the features. Yeah, I got a chance to have a quick view of this AIE repo, a first glance. Um, I think we have a bit around beyond the current stage of this AIE, because we have implemented some more great specific features and tested in our hardware, not by CI. So my question was how we could contribute or collaborate with the AIE. Do we need to start with web, or do you want to for some PRs? We have a bunch of PRs, and yeah. So what is the best way to collaborate?
I think initially with if we're talking about KubeVirt AIE PRs initially, and we can start a VEP for 1.9 in parallel to that. If you've already got code that you're willing to upstream into that project and land there, then yeah, we can do both in parallel, I think, and discuss the actual the design of everything in the VEP for 1.9, and just treat the current kind of branch in 1.8 as a an accelerated kind of development environment, if you will, where we can kind of work through the code that you have and the code that we have, and hopefully then design a solution that we can upstream in 1.9. Does that sound good, Vladek, to you?
Yeah, absolutely. Yeah. So, for example, EGM is a bit. I'm a bit hesitant, but yeah, I mean, we definitely can. If there's a PR, we can definitely test it.
Yeah, I thought EGM, like you said, it was out of scope at the moment, and the Vert folks, even within CentOS, hadn't really got that far yet. So I'm intrigued to
Yeah.
see how that's been enabled and what patches we're potentially missing as part of
Yeah.
this effort. But yeah, if
Yes.
we sorry, go on.
Yeah, sorry. I wanted to just jump in really quickly. I think Fan. I think what we need to do here is I think we need to get what you've done. I think we need to get you onto the AIE branch, and I think to do that we need to take the changes that you made and push them as pull requests, and the ones that like we're talking about EGM, but we're not sure. This is exactly the point. It's like we should discuss this and figure out like what is the near term and what is the long term solution that we can support in this repo. So I would say like let's find the delta that you have and let's try and get these as issues. There'll be some. We'll have the VEPs we'll track in parallel as our tie-in back to KubeVirt, and then we'll have these issues and PRs that you have in AIE, and let's just take that delta down as small as possible and get to a point where ideally you're just running AIE.
Yeah, that's perfect.
Yeah, yeah, makes sense. Yeah, yeah. Agree. So regarding to the EGM, I think that's a thing. First thing, I think, I have some discussion with NVIDIA kernel team that that maintains the GitHub NVIDIA QEMU and the libvirt patches. I think the Red Hat, I guess the Red Hat, your the Red Hat team, who is responsible for making the RPMs in the CentOS, hasn't picked up the latest fixes for the EGM. So the Red Hat for NV, as I heard, they might not uh, put the EGM as the first release. Uh, for I don't know for some reason. So in the CentOS RPM, it most likely lacks some critical EGM support. But for our downstream work, we're using the latest development code bases to build the RPMs. So VEGM is supported in our downstream. So that's a diff we need to call out.
So, Fan, I have a naive question here. For EGM to work correctly, do we not need all of the IMAX daemon work that is still pending?
So the EGM can work without IMAX as long as it in the same rack.
I see.
I mean, I just heard from the from the platform team who was testing AGM that they broke their nodes. So I don't know. Maybe some of the patches are missing there, but I mean, essentially, we need to wait for someone to provide us with the kernel, and it's not us. I mean, someone will need to put this in the QEMU. Sorry, in CentOS releases, and then we can consume it.
Yeah, it's through the SIG, Vladik. So yeah, it's not vanilla CentOS. We're not waiting that long, thankfully.
No, but I mean, my point is that we don't have a control over this. I mean, we could request things, but we just pulled the latest, but I'm not sure how it trickles down there.
Yeah, true. Yeah. Okay. And found just another silly question. For all of the things that you've listed here, to get them to work in your downstream, is this all possible without user-facing kind of API changes as well? Is there, for some of these concepts, are there things that you've had to express through a VM or a VMI or something to get this to work, or?
I'm sorry. Can you say that
Sorry,
again?
I'm just so as we kind of were talking about beforehand, with KubeVirt AIE, like the one deliverable that we have out of that project at the moment is just the launcher image itself. We're not looking to kind of ship anything more potentially if we can get away with it, and just run it against a vanilla 1.8 environment. For your work to enable all of this in your downstream fork, have you extended the API, or have you extended anything else outside of Virt Launcher, or is this all just within Virt Launcher?
Yeah. So yeah, that's a good question. That's another topic I wanted to discuss. So to support these great specific features, um, we do need a lot of work to change in the contract. Either so my solution currently is a two phases. Phase one is using a annotation approach, which is a smaller changes and easy to implement. And for the long term, we might need to migrate to the API style changes in the VMI, right? So I'm also wanting to discuss with you what would you believe is a better approach to be accepted by the AIE?
Annotations in the AIE changes is fine, like as a temporary solution, and then we can discuss user-facing VMI, VM API changes in the enhancement in the longer term. That would definitely work for us, again, because of the constraint that we've got. Assuming that all gets passed down, and this is all self-contained still within Launcher. Yeah, go on, sorry. I was going to say it's a self-imposed constraint, so we can always potentially change it as well. Like, yeah, we've tied our hands behind our back a little bit with this one, but we might be able to change that.
I just wanted to mention, even though it's only annotations, I don't think the launcher can see them, right? So it's still not possible to get data inside the launcher via annotations, if I'm not mistaken.
No, you're right.
It would still require the handler or another component to write those things into the launcher.
Annotation and downward API. I think we'll have to combine those.
Yeah, but I mean, before we get into this, I really invite you to review the work that we've done in AIE. I'm not entirely sure what we need the API for, but some of these things we kind of in query and infer from the kernel within the Virt launcher, so we don't need any additional configurations. For example, IMMUFD provide us with the hardware info, so we can open the device and then read, for example, things like all the SMMU configurations. We can read from there, and then a bunch of other things. So I just, before we go to API, I just please take a look at what we've done there.
I have a little bit of a tangential question. I heard a bit back that there was no plans on providing builds for KubeVirt AIE. If a user in the community wants to consume the work that is done in AIE, what would be the best way for them to do that?
So we will be providing the launcher builds for now, and if there's additional components that we end up needing to ship, we'll build those as well. You can just consume the repo as is and build everything as is. So the functional test builds everything from the repo and runs it all there. So there should be that there's limited coverage that part that will work, and it will just self-host and everything. But the downstream target for this is obviously to run it on top of a vanilla release 1.8 kind of environment. So we're only shipping the artifacts that we need at the moment. If folks end up wanting us to ship more and have a version of it shipped or something, we can potentially look at that. But for now, that's all we're shipping.
Makes sense. So what you're really saying is that if you have a vanilla KubeVirt running, and if we just override the Virt launcher image to be used that is shipped from this fork, then you should ideally be able to start a VM with that Virt launcher image on the hardware that you are testing. Right? Is that correct understanding?
Yeah, correct.
Yes.
You'll need the device plugin as well,
Sure.
running alongside it. But yeah, with those two things, yeah.
Yeah, cool. That makes sense. Think it might be worth it to call this out in README somewhere in bold letters. I think to me, this is a very easy path to consume with the work that is done here, and it just needs to be out there, if not already.
Yeah, I'd love to put it in the README. We are rebasing this on the release branch itself. I guess we can take that. The README is not going to change on the release branch. So yeah, I can start hacking up the README. I just wanted to I didn't want to touch anything that we didn't need to, just to make rebasing and keeping this up to date as easy as possible. But yeah, I can write an action down and make that clear in the top level README for folks.
Maybe instead of a README, we can add a completely new doc. So of course, it's not gonna give you any conflicts. But
yep,
just
sure.
a suggestion.
Yeah,
I don't know.
it should be trivial anyway to avoid it. But yeah, that we could do that as well. Thanks.
I also wanted to share how I tested the downstream work. We Basically, we do the manual test. We deployed the KubeVirt, the downstream KubeVirt images into the GB200 hardwares. We have a multi-node hardwares, GB200. So our VM model is a computer tree size VM, which converts, and the manual model is converting the whole computer tree into one single VM by passing through all the GPUs, NICs, and hardware resources into this VM, and running the AI workload inside the VM to achieve targeting to achieve bare metal best performance for the AI workload. So we created the VMI spec using the annotations and the feature gates that we implemented and designed and implemented, and launching the VMI on the single node and the two different nodes. So testing the AI of the CUDA's Senate CUDA test and verify the PCIe NUMA alignment and all the specific grades features is populated and generated correctly for the guest. So yeah, so that was it.
So one giant VM per node.
Yes.
Okay, and what did you need to look? I would assume that this just works out of the box, isn't it?
Yes. So for the yeah, you mean the source code?
By the way, is it a rootful VM?
Root for VM? Yeah, you mean the
No, the Virt launcher itself, is it root?
it's a it's a it's a regular. I didn't specify root for. I didn't specify privilege or root for the Ver launcher pod.
Okay, perfect. So okay, so it's just one VM. That's why I guess you didn't hit the problem with the memory accounting because I mean memory accounting by default is being done per user, and the problem here is that the moment you have multiple VMs, they all use the same user QEMU, and then the memory accounting for MMUFD is just immediately off. That's why we need the device plugin. And yeah, okay.
Yeah, I think the memory. What do you mean by the memory counting?
IMMUFD counts memory per process. Sorry, per user, and we need to. I mean, what if you want to run on the same node multiple VMs that are using the same IMMUFD? Then basically you need to change the mode IMMUFD operates into per process, and then for this you need someone privileged to do it because Virt Launcher cannot do it.
Yeah. So yeah, because we are using the one VM per tray, so yeah, we don't have this issue.
Yeah. Okay. Yeah, that's good. By the way, how did you guys overcome? So there was an issue recently, like very recently, where libvirt would a memory leak on these platforms because there's a parameter that basically sets how many CPUs are on the platform, and then it just opens like millions of structures. For some reason, the firmware reports like an enormously huge number for whatever reason. But did you experience any memory leaks, or you just didn't notice?
Yeah. I think there are memory. Yeah, there did a memory leak in the our launcher pod when running the QEMU. I think that's a bug in the QEMU. So the NVIDIA, yeah, we have a NVIDIA patch on the QEMU side to fix this issue. So as I said, we were using the internal development folk over sorry, not folk, internal development RPMs that building directly from the NVIDIA QEMU and NVIDIA LibVirt. So we have that fixed. I'm not sure if the RPMs you are using has carried this fix. So I can share more information with you offline. Yeah.
So there was something else which is libvirt related because it was looking at this physical package ID from sys, and there it was an enormous number that basically forced libvirt to create a huge amount of structures and keep them in memory. So I don't know if the bug is open.
Yeah, I know what you are saying. Yes, that's the same issue. Yeah, that's the one I pointed to. So that's a hardware issue. That's a physical ID, right? The physical ID is abnormal. It's very large, so it will causing the memory structures very large in the QEMU when it's iterating when it's doing the iterations. So the fix there is open source. There is upstream commit to fix this issue in the libvirt, and uh, NVIDIA just cherry pick that upstream.
Yeah. Maybe that's the one because we had to solve it just recently. So yeah, Lubo pointed to the bug. It's already in that Virt launcher that we're building, so that should be okay already.
Okay, we are pretty much at the top of the hour. So it sounds like we've got a couple of things to kind of work on and do before the next meeting that I believe is on the 9th of April, because this is an ad hoc one. Let me just double check. Yeah, so normal time on the 9th. Does anyone have any final questions, thoughts, or anything they want to share before we wrap this up?
Oh, thank you all for joining. I kind of have to drop. Sorry.
Yeah, no, all good. Thank you all. Thank you for your time, and yeah, catch you in the next one. Thank you. Bye.
Thank you.
Thanks,
Bye.
everyone.
Yeah, thank you.